Okay, in this lesson we're talking about traveling around networks. And once again, much like the first lesson in networks, it's all about vocab really. So as I said in the first lesson, this is an area for some little flip cards just to remind yourself what these terms all mean. There's sort of multiple choice question fodder, or maybe in a multi-part question it might be the very first part of that multi-part question. So make sure you understand what each of these terms mean. You need to be able to just quickly be able to explain the difference between a trail and a path, that sort of thing. Okay, so here's all our main terms that we're concerned with, but particularly the first five. So you've got a walk is just a series of vertices connected by edges, and in a walk you can return to edges, you can return to vertices as many times as you want. There's basically no rules with a walk. As long as the vertices are connected in your network, you can move between any vertices and edges as many times as you like. So it's the trail, the circuit, the path, and the cycle that have some limitations. So in these two, a trail and a circuit are very heavily linked together. They sort of go together, and a path and a cycle are linked together. So we'll start with the trail first. So a trail is concerned. Trails and circuits are concerned with edges, not so much vertices. So in a trail, you can't repeat an edge ever. You can go back to a vertex, but you can't ever go back along the same edge again. And a circuit is a trail that closes. So essentially, we come back to whatever the starting vertex is, we come back to that starting vertex at the end, but otherwise we follow all the other rules for a trail. We can't repeat edges. Now, a path has an extra restriction. As well as not being able to repeat edges, we can also not repeat vertices. I suppose that pretty much says it. A cycle, however, allows you to repeat just one vertex, and that's the one you start at. So you can't ever go back to any vertex except for the one you started at, which is where you have to finish. So a cycle is a closed path. All right. There are two other terms here, which I think we might have even mentioned in previous. I think a connected graph was mentioned. Maybe it was not. So a connective graph is one where you can get from any one vertex to any other vertex, even if you've got to go through 100 different vertices to get there, as long as you can get from any one vertex to every other vertex. So if we think about the national highways in Australia, if we think about the Australian mainland, all of the major capital cities are connected by that network of highways. However, when we remember that Tasmania is a part of Australia as well, those national highways don't link Hobart to Melbourne. There's no road I can drive on between Hobart and Darwin, for instance. So a network map of the Australian major highways that link our capital cities would not be a connected graph because we can't link Hobart in. Now, a traversable graph, and we'll deal with this a little bit more in another lesson, deals with one where we can draw it without taking our pen off the paper. So to give you an example here, if I draw myself a couple of little dots here, if we think about a capital A, and if we think about a capital B, in order to draw a capital B and a capital A, I'll start with the B first. I can draw the B without ever taking my pen off the paper and without ever traveling along an edge twice. So a B is traversable, because in doing that, and I'll run that through one more time, I can do that a couple of ways too. I can go this way, and to do that I haven't had to take my pen off the paper and I haven't gone along an edge twice. However, that's not possible with an A. If I start here with the A, I'm going to get up here, and then when I get to this spot here, I've got to go either down to the bottom of the A or across here, but once I do that I can't go back, so I'm stuck. There's no way to draw the A and make it traversable. So an A is not traversable, but a B is. And you can sort of think about the other capital letters and whether or not they're traversable. So just going through that, just to give you some examples, we want to use each of these paths. So a walk, anything goes. So with a walk, we've got to start at A, so we could go maybe A, C, D, B, and then A, C, F, something like that. So if I follow that now, I could go A to C. What did I say next? C to D. And then I would go back to B, and then I'm going to go back to A again, and then back to C again, and then I'm going to go along to F. That's perfectly acceptable in a walk. Okay. Now, we couldn't do that with a trail because we repeated that edge between A and C got repeated there. So if we were doing a trail, we could, for instance, do A, C, D, F, G, E, D, B, for instance. So let's just see what happens there. So we go A to C, C to D, D onto F, then onto G, onto E. Now we're going back to D. Although we've been to that vertex before, we're not going to use any of the edges we used before. And we're going to go to B. So that's perfectly acceptable. Although we went back to D, we use that vertex again. With a trail, it's only edges we're not allowed to repeat, and we didn't copy any of the edges. We didn't do anything like in that first example between A and C. Now, a circuit is a trail that starts and finishes in the same spot. So for this one, I'll do a rather simple one. I could do A, C, F, D, B. Actually, I won't do it that way. I want to repeat a vertex. So I'm going to go A, C, D, F, G, E, D, B, A. Just to show that. Where do I go to next? D, F, G, E. I can still go back to D again. I just can't use that edge again. But I have to get back to A. I have to start and finish. The start and the finish of my circuit have to be the same. Okay, so for a path, I need no repeated edges or vertices. So for this example, I'm going to go A, get back to a pen, A, C, D, F, G, E, B. And so as I do that, A, C, D to F, then on to G, then on to E. At this point when I'm at E, I can't go back to D. I could before, but now I'm not allowed to repeat vertices. So because I've been through that vertice before, I can't, but I can go here to B. So that's my path. And the cycle, I can do pretty much the same way starting at A. I've just got to get back to A. So I could do that same D, F, G, E, B, A. So exactly the same as that path, but adding on the spot to come back to A. So my start and my finish has to be the same. Now, I could have done another path on this particular one. I could have done A, C, D, B, A, for instance. A, C, D, B, A. And that would be a valid cycle as well. So these are only examples. In each of these drawings, these are only examples of each of the methods of travel around a network that could be used, but each of these would allow, there would be other ways of solving this problem in each of these graphs. With that, get yourself stuck into exercise 2B. Just remember some flashcards or something like that to remember these terms would be really, really helpful, because they're the sort of things that you're likely to get asked at the end of the year. It's expected that you'll know the difference between, for instance, a trail and a path. Alrighty.